Hello, grade 4 teachers. Let's have a look at some ways that you can connect computer science into your living systems unit. You already know that the organizing idea for computer science, all the way from kindergarten through grade 6, has to do with creative thinking, design thinking, and computational thinking. To cover off the gaps that may not have been taught to your students because they didn't get computer science in a younger grade, you can easily make connections to just following instructions within your classroom to cover off most of kindergarten through grade 2 informally. If you talk to your students about how something that they have learned to do, for example, what happens when the recess bell goes, we have a set of steps that we carry out, just like a computer or a machine. I, as the teacher, programmed you guys, like my robots, to do a certain algorithm when you hear the recess bell go, or when I raise my hand up, or turn the lights off, or you're finished an assignment or a test. There's all kinds of algorithms that I have programmed into you guys to help our classroom routines run smoothly this year. So making a reference like that covers off those first few learning outcomes, and it makes that connection between how the types of algorithms that we write for computers and grade 4 students will be asked to write as a part of their computer science curriculum are very much like the kinds of instructions that we follow as humans in every day of our life to accomplish certain tasks. There is a lot in the knowledge column in the grade 4 computer science curriculum. We aren't going to talk a lot about the knowledge piece when we're doing these connections, but we will be looking specifically at the skills and procedures and then referencing where the design process comes into play in places that you can explicitly bring that into the other science lessons that you're doing in your living systems unit. Just some more of the knowledge. In there, we do see the line for algorithms, models, prototypes, blueprints, experiments. These are things that you're going to be coming into contact with in all of your other science units as well as in other subject areas. So these live in the knowledge area in the computer science. So when we're asking students to create these things, we're going to be asking them to use the design process and then just by design, also touching on this computer science curriculum. Creativity, especially in the science when it's coming through, starting heavily in grade 2, and then we see it mentioned throughout the rest of the curriculum. In a word cloud, it was one of the biggest words there, with all of the different cusps and organizing ideas and learning outcomes dumped in together. Creativity, coming up with new ways to solve a problem, finding a different path to the same solution. This is the kind of creativity that we'll be wanting our students to use when they're carrying out science experiments. And this is a piece of the computer science, again, that we can touch on in all areas of our teaching and daily routines. The design thinking process, your grade 4s are being asked to learn about this explicitly. So as we're performing experiments, doing investigations, we're going to make reference to these stages of the design process as we work through them and make that connection for the students as well. Computational thinking is also going to be used all throughout your science topics as well as throughout your daily teachings and classroom routines. There will be plenty of opportunities to make reference to these different pieces of computational thinking and then make that natural connection through to how that connects to the computer coding and algorithm design of artifacts that are in a machine or robot or computer type nature. Jumping into the living systems, learning outcome about organisms and their external structures and functions. We are going to probably be doing a lot of comparing and sorting type activities where we're looking at different attributes of living organisms and comparing them to each other and grouping them according to a certain thing. So we could be talking about appearance or habitat or structures. Look at this example where we are dividing plants into ones that grow seeds and ones that don't grow seeds. For this particular sort, we are using our computational thinking because we are decomposing these plants that we're looking at. We don't care if we eat what they produce. We don't care if we use them in some other way. We don't care what kind of leaves they have. None of that matters. Our job is to look at whether or not they produce seeds. If they do, they go here. If they don't, they go over there. There is that if statement that can be connected specifically into algorithm writing and algorithmic thinking. Ask the students to create an algorithm for this sort. We're learning about the attributes of plants. We're also learning about computational thinking and our computer science at the same time. We can connect anytime we're looking at in our living systems unit the attributes of these living things. We can have conversations about what makes them the same. What if we're looking up specifically for this type of sort, now labeling plants according to these titles, we can have conversations about, okay, so how do we know that that is a tree? Can we come up with a set of instructions that would help a person who doesn't know what these things are sort them just by looking at the pictures and seeing what our conditions are? Could we create a program that a machine could use to identify if these are vines or herbs or shrubs? And then we can move into that algorithm design, which we have a specific skill and procedure right out of the computer science curriculum talking about designing algorithms. If we're doing that together as a group, if two students are doing it together, we're collaborating on it. So a simple algorithm can come out. If it has a trunk and branches, then it is a tree. And then maybe we test this off and we're moving into some of that design thinking. Well, how is our algorithm any good? Let's look at some trees and see if all of the trees that we find meet this condition. Now let's look at some other plants that have one or two and possibly two of these conditions. Are there any others? Is our algorithm for a tree going to be useful, but for a machine, is it going to work? So we are incorporating the computational thinking by breaking these pieces of these plants down into their parts, looking specifically at attributes. We're looking for patterns that make something a particular type of plant. We're abstracting that into other plants to see if those same patterns can be applied and if they confirm the pattern that we've created. And then we've really, we're creating that algorithm just by creating a simple if-then statement. So lots of computer science going on while we're also learning about the attributes of plants. We wouldn't traditionally probably put empathizing into dealing with living systems or animals, but I think empathizing is a tough thing to teach students, and any opportunities that we can have to make a connection about it. So we learn traditionally about empathy, about putting ourselves in someone else's shoes. Animals, we can put ourselves into their position too and have conversations about how, will the animals feel if we aren't respectful of their habitats and their homes? And how will the animals feel when their homes disappear, or whatever other things we discuss when we're talking about respecting our natural local environments. So there's a design piece, an opportunity to connect into and give students a deeper understanding of what empathizing means, and then that in relation to the design process. We have two computer science skills that are really specifically about creating an artifact and an algorithm, which it doesn't say it has to be a computer program or some type of machine program, but it definitely can be. That's going to give the kids that foundational skill and connect into coding. We know that coding skills should be taught as early on as we can for students, not just because we have a new computer science curriculum, but because we know that the world that the students are growing up into is going to be much more accessible to them if they have a handle on what computer coding is. So connecting these outcomes into a specifically coding activity is a really good thing you can do in grade 4 to anchor that for students and give them that extra little bit of lift up in learning into the coding skills. This is a project that they can do in Scratch. It's pretty straightforward. If your students have used Scratch before, I would even venture to say they could build this activity easily without the given template. I do have a template for the Scratch project. Going to this bit.ly or using this QR code will take you straight to Scratch to this project where you or students can click the green remix button and turn it into a new copy and start building. So all of the sprites and the backdrops are there and none of the code is in that template. There's also a set of cards. They're just a set of slides that you would access with the other link, and those cards go through and specifically show exactly the bits of code that need to be added to the sprite. So again, depending on your students' level of experience with Scratch and where they're at, you may just give them the project, ask them to show that they know the parts of a plant through a Scratch project and to create a game that their classmates could play. You could also give them that guided lesson and have them work through the steps that I've given with the instructions and do it that way if they're less experienced as well. I like to create my sprites and my backdrops in Canva. If your students have access to that and are already familiar, they would be able to easily go there and do the same to create their own custom projects as well. You have another skill in living systems about comparing the structures of plants and animals, and there would be many activities that you could do with your class that would have them looking at specific parts of plants or animals. Just looking at a sample activity, couple of activities here that are just basic labeling the parts of a plant, and we're looking at a fruit-bearing plant in comparison with a coniferous tree. And we can talk about comparing what's in the boxes for each of these activities, what's the same between these two different kinds of plants, and what's different. And when we start to have these comparative conversations, again, we're activating that computational thinking. We're decomposing. We're going to look at just the roots right now of each of these. That's the only thing that matters. Let's make that comparison. We're going to ignore everything else and just focus on the one thing, and then we'll determine that the roots, they have the same purpose. So can we come up with a general algorithm for something about roots? And well, something that if it's a plant, it has roots, and then we can test that and see, are there plants that don't meet this condition, and just work through that computational thinking, make those connections. If you can take any type of an activity that you're doing like this and then expand it and ask the students, could you write a set of instructions for someone who's never seen this and doesn't know how to do this activity? You're going to level up their critical thinking skills. You're going to connect into computational thinking, and you're going to be covering those CS outcomes as well. The same would go when we're looking at animals. This kind of a sort, we can have those conversations about why don't any animals only have wings. If we're talking about how an animal moves, does it matter where its eyes are? Does it matter what it eats? Does it matter where it lives? No, if we're only talking about how it moves, we're decomposing it all out. We're focusing in on the parts that make it move and how it moves, and then putting it into these groups. We can then have further conversations. What other kind of animals belong in each of these categories? And now we're going to take that pattern that we have recognized within these animals, and we're applying it to some other animals. And then we could even move further to go ahead and create those algorithms with the if-then statements. And could you create a set of instructions that would help another human or a machine complete this sort? And you're going to be connecting not just this living systems content that you're covering, but also bringing in that computer sciences understandings as well. We can build those algorithms with the if-then statements. You have the specific learning skill in your computer sciences that's talking about creating algorithms. So again, that can be the types of algorithms that we're building in a Scratch program or with working with something like microbits, but it can also just simply be something that we're saying in plain language. Pseudocoding in plain language is a skill that helps students move to the actual logic coding in a block language or further onto a language-based programming language. So just covering this anytime and just breaking it down simply, stating it in the same sort of way that you would a computer code with an if then conditional type statement, maybe putting a repeat where that applies and referencing the loop, or just drawing those computer science concepts into the other things that we're learning. Another connection you can make on this particular skill and procedure in your living matters is if you have some type of robotics or other electronics that you use for programming in your classroom, like microbits, you could make references to how the sensors on a robot or a machine are similar to the sensory organs or the parts of a plant that receive sensory stimuli, and that when they receive that stimuli, something happens. And in that, you can make a connection that machines really imitate living things, and how those sensors function in the same way that, say, our eyes see the cameras on a robot have that same function, and it's created in replication of our sensory organs or the parts of plants that are sensory. So that's an extra connection that you can make there as well. When you're asking students to conduct an investigation or do an experiment or build some type of a model, you're going to be asking them to work through the design process, and you can work through it specifically with them and design your activities in such a way that it's going to take them through those different stages of the design process so that they're doing it and thinking about it while they're also connecting this other idea that may come from living systems or any of your other science or other subject area topics. And while they're working through the design process and creating something or doing an investigation, they can also cover these curriculum outcomes from the computer sciences area when they're working with each other and providing that feedback, maybe designing an algorithm. That can be an algorithm like we're building in a Scratch program, but that also can just be a set of instructions. How are we going to perform this experiment? Write out the steps in order. We're creating an algorithm. And we can also have conversations or have students analyze about the materials that they're using for their investigations or their models or their experiments. We can see what things are, talk about what would be better that we don't have available, for example, in the school setting. Or why do you think we don't have this material available? And maybe the cost conversation comes into play. So we can connect this computer science piece in while we're doing not just this investigation in living systems, but any investigation or experiment or model building. So those are some ways that you can connect computer sciences into your living systems unit. You can probably connect in other ways to other subjects as well. I hope you enjoyed.